Hello everyone, this is the first lesson recording for IM2, April 15th, 2021. As a warm-up, I want you to try to find the area of the following regular polygons below. Okay, the first one you should definitely be able to do because that's the lesson that we covered. The B, C, and D, you might have trouble with it. See if you can struggle with it. We're going to go over the answers in a little while. First, announcements. Quiz number 4 is going to be happening next class, and it's going to cover polygon angles, interior and exterior, and special polygon area and perimeter. So you should be very familiar with homework number 18, 19, and 20. Also, remember that IM2 Study Hall tutorial is happening on Tuesdays and Fridays at 10:20 to 10:50. So especially if you are struggling with this unit, okay, at the beginning. If you're having problems with it right now, then you're going to have much bigger problems later on unless you clarify any misconceptions. So please attend the study halls on Tuesdays and Fridays. Goal for the day, we're going to continue area of the regular polygons level 2 and also area and perimeter of similar shapes. So now let's get back to the warm-up problems. You were supposed to find the area of the regular polygons. So how do I do this? Well, you can just memorize the formula, but you know what? Much better would be for you to understand where the formula comes from. That way, even in a year, 2 years, or 5 years time, you can figure it out just by looking at it. Right, so how do I do this? If we know that to be a regular polygon and we are told that they were, then what we can do is we can create lines or radii, extend the radii from the center to the vertex. So you're creating congruent triangle. This is 1, 2, 3, 4, 5, 6, 7-sided. That means whatever the area of one triangle, to find the area of the total septagon, you need to multiply that by 7. Okay, so what is the area of the triangle? So area of the triangle is going to be, well, what's the base? Base is the same as the side length. So the base is 10 units here. 10 times base times height, half times base times height. So it's going to be half times base, which is 10, times 10.4. Okay, so that's going to be same as, which is 52 if I use the calculator. So I figured out the area of one triangle being 52 units square. So the area of the septagon, so for this septagon, is going to be 7 times 52. That's going to be 364 units square. Okay. So that was part A that you should have been able to do. Yes, you could have used the formula of area is going to be apothem times side length times n divided by 2. But it would be far better if you understood where the formula comes from, because then you don't have to memorize yet another formula. All right, so then what about B, C, and D? Well, we're going to come back to this. So before we do that, let me show you something else. So area of regular polygon level 2. This time we have 1, 2, 3, 4, 5, 6, 7, 8-sided polygon, which is an octagon. And we're given the radii, the distance from the vertex to the center of the polygon. And we know that we have one triangle there and another triangle there, and 3, 4, 5, 6, 7, 8 triangle that are congruent, because this is an 8-sided polygon or octagon. So 8 sides means there are 8 congruent triangles. Now let's look closely at the triangle itself. Okay, and if I just blow that up, what is the value that we are given for that triangle? we're given that the hypotenuse in this case is 14.5. So try to just bring this triangle and blow it up, okay? And this is the hypotenuse of the right triangle here. So this is going to be the 14.5. Now, what else do we know? We know that if that is 14.5, the other radii is also 14.5. Okay, and do we know the central angle? Well, we know the whole revolution. Okay, when you make a full circle, it's going to be 360 degrees. So 360, and that angle, that central angle is this angle right at the top. And that angle, and and we can figure that out in a minute. And to figure out the area of this triangle, we need to figure out the apothem, or in this case, the height of the triangle, which is the same as the apothem, and also the side length. Okay, so we need to figure this length out, and then when you figure that out, we know that this is going to be exactly congruent, so same in length, so then we can figure out the side length or the base of the triangle. So let's start by the central angle. Central angle, because we know that the full revolution is going to create 360, there are 8 central angles. Since there are 8 central angles that multiply to 360, so 8 times whatever the angle measure is 360, I can divide 360 by 8 to get that central angle to be 45 degrees. Now, once I found the 45 degree to be central angle, this angle is 45 degrees. But I know that this is made up by the angle on the left here, and the angle on the right here is going to be exactly congruent. So it's going to be half of 45 degrees. So that angle is going to be 22.5 degrees. Now, if I know the angle measure here, and if I know the hypotenuse of the right triangle, can we figure out the other side length? Yes, we can, and that's where the trig ratios comes in. If I was to figure out the height of this triangle relative to this angle measure of 22.5, this is going to be the adjacent side. So, which is the trig function that deals with adjacent, and this is the hypotenuse, that's cosine. So we can set up the equation as cosine of 22.5 degrees is adjacent of a hypotenuse, which is question mark length, divided by hypotenuse is 14.5. And using the calculator, multiplying both sides by 14.5, that gives us that question mark length to be 13.4 approximately. We figured the apotheme's length now. Now we need to figure out the question mark. Okay, this relative to the 22.5 degrees, this is the opposite side, so it's opposite, and hypotenuse, we're going to use sine of 22.5 degrees is going to be opposite, which is the question mark, divided by 14.5. Use the calculator, figure out what sine of 22.5 is, multiply by 14.5, and you should get the length of the question mark to be 5.55. Now this is really important. Don't just rely on the calculator to give you the answer. When you think you have the answer, you should always check to see, now does it look about right? Okay, does it look about right that this should be 13.4 and this should be 5.55? Yeah, 13.4 is smaller than the hypotenuse. Remember, hypotenuse is going to be always the biggest side length of a right triangle. And it does look like this is going to be a lot longer than this side length, right? So if the fact that we got 13.4 here and 5.55, that sounds about right. Okay, so then I know to figure out the area of the triangle. Triangle is going to be half times 13.4, that's the height, times what is the base? Base is this question mark time length multiplied by 2, because the base is this total length. So it's going to be 5.55 times 2. Use the calculator and you should get 74.37. So we've just figured out the area of one of these triangles. One of this triangle here is 74.37. To figure out the area of this polygon, since there are 8 congruent triangles with the area of 74.37, we have the area of the octagon is going to be 8 times 74.37, which is going to be 594.96 units squared. Okay, so we've just figured out how to do that when we don't have the apothem. If we are given the radii instead of the apothems, then we can still figure it out using our trig function. Okay, so now that we know this, let's see if we can tackle B, C, and D. Okay, and it's the same principle being used for C as to D, right? So let's see if we can work on those. Okay, so for B, the first thing I'm going to do is count how many sides we have. We have 5 sides. So we have 5 sides, that means it's a pentagon. And I can draw my triangle here. And I know that we're given the radii and the side length. Okay, so we know that this radii is also going to be 4 because the radii of a regular polygon is always going to be the same. Okay, now this time we know that the side length is 4.7. So if I was to split this in half, what is this length going to be? This is going to be 4.7 divided by 2. So it's going to be 2.35. And I know that this is also going to be 2.35. Okay? All right, so then, and we also know that this is going to be right angle triangle. Now we are given 2 sides. Now to figure out the area of this triangle, we need to get the base and the height or the apothem. But we know the hypotenuse length, so we can go into central angle and figure out the apothem's length. Or we don't even have to go there. Since we know the hypotenuse and the length, we can use Pythagorean theorem here, right? So if I say apothem's length is x, let's set up the equation. So we can say that x squared, the leg is, one of the leg is x, plus 2.35 is another leg, is going to be the hypotenuse squared, which is going to be 4 squared. So x squared is going to be 4 squared, which is 16, minus 2.35. 2.35 squared is 5.5225, and subtract that from 16, I get 10.48, and take the square root of 10.4775, and I get x to be 3.24. So I found the apothem to be 3.24 approximately. So the area of the triangle is going to be base, which is 2.35 times 2, or 7, same as 4.7. So it's going to be half times base, which is 4.7, times apothem, which is 3.23, or 24. And if I use the calculator, so for the area of the whole pentagon, it's going to be 7.61, the area of one triangle multiplied by 5. It's 5-sided. So that's going to give us 38.0 units squared. Okay, let's tackle C. To do that, we're told that the apothem's length is 14.5. Okay, this is apothem's length. And we do want to create our triangle like so. And we know that this is 8-sided, so it's an octagon. Now, we're just given the triangle. So we're given the apothem to be 14.5. The central angle in this case is 360 divided by 8. It's 8-sided, so it's 45 degrees. And that means that this angle measure here is going to be 22.5 degrees. Now, we still need to figure out the x. And how do I do that? This is where the trig function comes in, which is the trig function that deals with, this is adjacent side, and the opposite, that's going to be tangent. Okay, so tangent of 22.5 is going to be opposite SOHCAHTOA